Okay, we're going to continue with linear inequalities, but now we have a slight variation. We're going to review absolute value. Okay? One thing that we have to remember is that absolute value, represented in those two lines circling the A, represents a absolute value, meaning that any value that is placed on that variable is always going to end up being positive. Okay? Usually absolute value, we're using it when we're talking about distances. Okay, so even if we are talking about distances in negative numbers, we have to take into consideration that distance cannot be negative. Okay, so that's why it always has to be positive. Okay, and that's why it's encircled in those symbols. Okay, so for example, if I were to say I ran 3 kilometers today, okay, that's a positive distance. Can I say that I ran negative 5 kilometers? No, right? Okay, because a distance, by definition, is always positive. Okay, so when we are talking about inequalities and we're talking about absolute values, okay, we have different rules. Okay, so let's review those rules. When we have the absolute value and we have a less than a value with the b, okay, we have to convert this inequality into negative b less than a less than b. Okay, the negative on this side, positive on this side. Okay, this is when we have a less than. Now, if an absolute value, we have it as a greater than b, that means that a is greater than b and that a is less than negative b. So that means that we have to join them, like we saw in lesson 2. Okay, these are combined inequalities. And when we have that the absolute value is equal to b, that means that a can be b or a can be negative b, because when we put it inside the absolute value symbols, it's always going to be positive. Okay, so we know that a can be b or a can be negative b. Okay, so let's apply this into the inequalities. Okay, the first one we have is a greater than 8. Okay, so let's get to work. Okay, when we have this, let's remember the rule. Let's take it up here. Okay, so we have a greater than b. Okay, so we need to separate into greater than b and less than negative b. Okay, so we put it like this. X plus 7, we just copy the first one, is greater than 8. But we also have that x plus 7 is less than negative b, which is negative 8. Okay, so we start to solve. Okay, this 7 is positive, we bring it to the other side, negative. So the symbol stays the same, so we have 8 minus 7. Okay, so we have that x is greater than 1. We do the same thing on the other side. Okay, x, this 7 is positive, we bring it to the other side, negative. So we have that minus 8 minus 7. So x is less than minus 15. Okay, so now that we have these two little answers, okay, we're going to work on the number line. Okay, once we work on the number line, we need to make one line graph for this one, line graph for this one, and then we can solve the solution set. Okay, let's do the line graphs now. Okay, so the first one would be this one. Okay, so we have that x is greater than 1. Okay, so let's put here 0, here's 1, and on this side would be minus 50. Okay, now let's remember, since these symbols are greater or less than, we do not include these points. Okay, so let's do the first one, greater than 1. We place the point, and we're looking for values that are greater than 1, so to this side. Okay, so all of the values to the right of 1, 1 not included, are going to make this true. Now let's do the next one. Minus 15, 0, 1. Okay, so we're looking for the values that are less than negative 15. So where to? We place the point first, and then the values that are less than negative 15 come to this side. Okay, now in previous lesson we talked about when we combine. Okay, where do they meet? Where do they share the values? In these two, there are no shared values. Okay, so when we put our solution set, we need to use a union, but a union that only connects them. Okay, so a solution set for this one would be coming from negative infinite, not included, because infinites are never included, up to negative 15. Okay? Oh, it's not going to fit. Let me put it here. Okay, so our solution set is going to come from negative infinite, not included, to negative 15. Okay? Not included. Okay? And we have to use a union to include the other ones. So we make a union, and they start again on point 1, but point 1 is not included. So we put from 1 to positive infinite, not included. And that's where we have our answer. Okay? When we work these inequalities, we have to work them separately. We need the two graphs. We would need a third graph in case they share some values. In this case, they do not share. Okay? And then we need to place the solution set. Okay, so this means that the values coming from negative infinite up to negative 15, and the values that take from 1 to positive infinite. Okay? Perfect. Now, how can we check if these answers are correct? Let's take some numbers outside and inside the number lines. Okay? For example, let's take -1, which would be here. This would be a number outside the number lines. Okay, so let's take -1. If we put -1 here, we would have -1 plus 7 is 6. Absolute value, positive 6. Is 6 greater than 8? No. Okay, so we know it's not true. Okay, so these values are correct. Let's try one inside the value. Let's say 2. Okay, 2 is included here. So 2 plus 7 is going to be 9, making it absolute value, positive 9. Is positive 9 greater than 8? Yes. Okay? Let's try with the other values. Let's try negative 20. Okay? Negative 20 is included on this side. So if we have negative 20 plus 7, it's going to be negative 13. But the absolute value makes it positive. So 13 greater than 8? Yes. Okay, so that's how we know that our answers are correct. Okay, so when we work these exercises, we need to work the two inequalities separately. We need to make the line graphs. We would need a third one in case they share values. In this case, they do not. And we need to place a solution set. Okay, just remember, where do we make this solution set? Answers coming from negative infinite up to 15, negative 15, but they are not included. That's why we have the closed brackets. We make a union because all of the values starting from 1, not included, to positive infinite, not included, are going to make this correct. Okay? Perfect. Okay, so this would be number 1. Let's work on the other one, which would be a less than inequality. Okay, I'll give you a minute. You can pause, copy, whatever you need to do. Remember that under this link, you're going to find some exercises. Under this video, you're going to find a link with some exercises that you need to work on. Okay, let's get to work on the second. Okay, now let's look for the rule for a less than inequality. Okay, we have it up here, so that means that we have to equal the inequality, okay, to the negative number, to the negative b. Okay, so if we start working, we would have this. 2x plus 15. Okay? Less than 11, but greater than minus 11. Okay? Once we place this, okay, we have to separate them again, or we can solve immediately. Okay, let's get to solving immediately.